you've looked on your Blackboard account, you'll see that there are the first two sessions have been recorded. If you missed anything or if you want to review anything, those two sessions are recorded and you can review. You can, and I will leave these on posted for the whole term. It's in the section that's called recordings, and it's always a good idea to check your Blackboard account to see if there's anything new that's been added that may be of interest. For example, in the weekly folder, you would see that there is a sheet that looks like this, which says practice examples sheet 1. Those are additional examples aside from the examples that are given on Delta Math. And actually, these are examples that have been given to us by the math department, which is essentially the type of questions that you'll see when you get to the final and the midterm. And not only did I give you the sheet for each chapter, there'll be a example sheet and an answer key. So that's for you to use for your own private purposes to review if you want more examples to review, or you want to see really the type of examples you might see on the midterm. They're good review examples. So there's all sorts of things on that Blackboard account that you really should be looking at. And I keep building on it. So don't just look at it today and say, oh, that's it. Every session, I probably put in additional work. I will always put in the recording, the YouTube of the class that will be entered after each session as well. Okay, so let's look at this problem. This problem is an absolute value equation. We're told that we have the absolute value of 4x minus 9. Remember, those two lines on either side indicate the absolute value, minus the 5, which is not inside the absolute value sign, equaling to 10. And we have to solve this absolute value equation. And we have to remember how to go about doing that. I see a bunch of people already have done it, and looks like there are some good answers there. So let's do it together. When you want to solve an absolute value equation, the first thing you want to do is get the absolute value all by itself. In what we call isolate the absolute value. Now there happens to be a minus 5 on the outside. So the first thing I want to do is add 5 to both sides of this equation so that we get that the absolute value of 4x minus 9 this equals 15. So that's step number 1. Make sure there's nothing else on the side with the absolute value. Any other numbers have to be on the further side. And then you have to break this. Then look at the number that's on the other side of the absolute value sign. It must be a positive number. If this would have turned out to be a negative 15 or a negative anything, you could have stopped right there because the absolute value always has to be positive. Well, this is positive. Since it's positive, I can go further. I go further by breaking it up into 2 equations. The first equation I get is simply the 4x minus 9 equals 15. I just drop these absolute value signs. The second equation I get is by doing the 4x minus 9 equaling negative 15. So one equation is with a positive number and the second equation is a negative number. The two equations are almost identical. The difference being that the number on the other side in one case is a positive number, on the other case it's a negative number. But in this case, the left side of the equation is the same for both, which means the steps involved in solving these equations is pretty much equivalent. Over here, I'm going to add 9 to both sides, which will give me 4x equals 24. And then I'll divide by 4. So that I'll get one answer being 6. Now, if that's where you stopped, you didn't finish the problem. And I have to tell you, in your midterm or your final, which will be a multiple choice test, unless they make changes, but which has been, for as long as I know, Math 136, the final and the midterm are multiple choice exams. If you just gave the answer 6, your answer is wrong because it's not a complete solution. You have to solve the second one, which will involve basically the same steps. You have to add 9 to both sides, which will give you 4x equals, well, now it's negative 15 and plus 9, which is negative 6. And again, you have to divide both sides by 4. That gives you a fraction as an answer. Now, negative 6 over 4 actually can be reduced. You can divide the top and bottom by 2, which will be in simplest form, negative 3 over 2. Both of these are answers, and you must give both answers. If you put this in your calculator and you got negative 1.5, that's also acceptable. Though when it comes to a multiple choice test, it will probably give you the fractional versions. It won't give you the decimal versions. So in order to solve this absolute value equation, we isolate the absolute value and then write 2 equations. Remembering this, initially, this number on the other side of the absolute value sign has to be equal to a positive number. And notice your answers can be either positive or negative, but your initial equation, when it's still in the absolute value, has to be a positive number. Okay, so this is, I think most people have gotten this now. I'd like to now do a few more things to finish up this chapter 1. And then at the end of the period, we're going to be starting with chapter 2, which is about graphing of lines. Let me just remind you that Monday, Tuesday, and Wednesday, there are no classes. We do not have class again until next Thursday. The other thing I want to remind you is always check to see if you have any new Delta Math assignments. Your assignments, your homework assignments, the ones that you're going to get credit for, will be on Delta Math. And I check constantly to see if those assignments are done. Now, if you miss an assignment, you can always do it a little bit later. You don't get full credit, but you do get 90% of the credit. And you have to have done the homework in order, that's about 10% of your mark, depends on having done the homework. When I'm looking at the homework, I'm not looking to see if you got the questions right or wrong. I'm looking to see, did you do the homework? The nice thing about Delta Math is that if you get the question wrong, you can then try another question. You can even, there are videos showing you how to do the question so that if you didn't get it right the first time, you get the next one, and it just does, you'll get 100%. If you do all the questions, even if it took you 5 tries, you do get 100% for the homework. Okay, so let's now look at one of the things that we didn't do before. And that's, we talked about solving equations. And we even solved those linear equations that had decimals in it. But I said, for the meantime, I was not going to do anything that had fractions. I'd like to do a couple of examples using fractions so that somebody had raised their hand, and does somebody have a question they wanted to ask me?
Yeah.
Yeah. Go ahead.
For the Delta Math the second assignment, I completed everything, but I got an 85 because for some of them, there was like only a certain amount of problems that you could do. So like once you did one, like you didn't get any more tries.
Okay, I know, there were certain problems that I had given you. It says that I wanted those specific problems done. In that case, it only gives you the one problem. The 85 is not a problem. What you really want to know if you have a question is how to do it. But when I look at that mark, I see that you did the homework, and therefore you get 100% for the homework mark. In other words, they're giving you a mark on whether you got something right or wrong. But when I give a homework mark, that's why I reinterpret the mark, and I see this 85, but you tried all the problems. That's considered 100% in my book. Is that understood?
Yeah, okay, thank you.
Okay. Did you figure out how to do those problems?
Yeah, I was just a little distracted when I was doing them.
Okay. Okay. Number one, sometimes that can happen, of course, and sometimes you get something wrong simply because you're not sure how they want it entered. So if you ever have problems entering things on Delta Math, you can always email me or you can meet with me. Again, my office hours are from 9:15 to 10, both Tuesday and Thursday. And I meet on this Zoom number. So you just can zoom in on the number that you have for our class, and you'll find me there. And if you want to have an individual discussion, we could talk then. If that time doesn't work for you, you could always send me an email and we'll try and figure out a time where we can meet personally that will be good for both of us. And of course, you can always email me questions. I might not get to with the next same day, but I certainly I check my emails at least once a day, and I try to answer everybody's questions. So just keep communicating with me, and hopefully everything will work out. These are relatively large. This term, they gave us pretty large classes. When you have 30 plus in a class, it becomes hard to do a lot of individual work. But again, anytime you want to talk to me on an individual basis, I'll make myself available for you. Okay, so let's look at a question that involves fractions. I'm going to show you a method that we can use to solve equations with fractions that, aside from the very first step, will make it easier. The problem is most people don't like to work with fractions. They forget the steps involved, and working with fractions, especially when it comes to adding and subtracting fractions, is a little bit on the difficult side. So I just want to first remind you how to multiply fractions, because we're going to be doing that. And then I'm going to show you a method that can be used to solve an equation that has fractions in it that will involve getting rid of the fractions so that eventually you have an equation to solve that doesn't have any fractions, which makes it a simpler equation. So first of all, let me remind you about multiplying fractions. Suppose I have 8/3 times 12/16. I want to multiply these two fractions. The basic rule in multiplying fractions is that you have to multiply the tops together. You have to multiply the two numerators together. And then you have to multiply the two denominators together. And that gives you your answer. In other words, I would do 8 times 12, which is 96, and 3 times 16, which is 48. That's the basic method. The only thing that's wrong with this method or makes it difficult is that you then have to reduce the fraction. And sometimes with this multiplication, you get some pretty high numbers. In this case, I got a 96/48. Now, if you notice, 48 goes into 96, so I could reduce this to 2/1, which is 2. That is one way of multiplying fractions. There is another way that will get you to the same answer that might make it a little bit simpler to do. I could first do something that's called cross canceling. Before I do the multiplication of the tops and the bottoms, I look if there's any way I could cancel out a number in the numerator, a number in the top with a number in the denominator. Any numerator with any denominator. Now, if you notice, the 8 here and the 16 here could be canceled out. I could divide the 8 by 8 and get 1. I could divide the 16 by 8 and get 2. I then go to my next number, which is 12. There's a 12 in the numerator in the top. Is there anything I can cancel out with the 12 in the denominator? And yes, I can cancel out the 12 on top with the 3 on the bottom. I cancel out this 3, gives me a 1. 12 3 divided into 12 gives me 4. And if I then multiply the numerators, I get 1 times 4, which is 4, over 1 times 2, which is 2, which still can be could be reduced, but it's a much easier thing to reduce. If I reduce 4 over 2, I get 2 over 1, which is 2. In other words, I get the same answer, except it was much simpler because I didn't have as big numbers to use. So if I can do this cross-canceling method, I do that. I'm sure you learned this sometime in elementary school. This is just regular number multiplying of fractions. Okay, that being the case, let me show you how we can use this to help us solve equations that have fractions in them. Suppose I gave you this equation. A over 5 minus A plus 7 over 3 equals -1. Okay. Using the method that I'm going to be using, I have to find something that's called the LCD, lowest common denominator. So the first thing I do is I look at all the denominators in my fraction, in my equation. Remember, the denominators are the numbers that are on the bottom. So the denominator here is 5. The denominator here is 3. Now, where you have a number that doesn't have a denominator, in other words, it's just a whole number, its denominator is 1. As a matter of fact, it's much easier to deal with a equation with fractions if everything is fractions. Much harder when there's a mixture of fractions and whole numbers. So that's always one of the first things I do. If I see any whole numbers, any numbers that don't have denominators, I just put them over 1. Now, the common denominator is a number that all 3 of the numbers will go into evenly. I usually do figure that out by picking the largest denominator, which in this case is 5. And I say, okay, can 5 be the LCD? Well, 3 doesn't divide evenly into 5, so it can't be the LCD because the LCD is a number all of them go into evenly. Then if it's not 5, it can write 2 times 5, which is 10, but 3 doesn't go into 10 either. And then I can try 15. Now notice 15, the 3 will divide into 15. The 1 will divide into 15. 15 is a number that all 3 of these go into. So one way of finding the LCD is just to take the largest number of the denominators and just keep multiplying it by 1, 2, 3 until you get something that all of them go into. An alternate method, it might not be the least common denominator, but they will always give you a common denominator, is if you just multiply the denominators together. 5 times 3 times 1 is 15. In this case, 15 is the least common denominator. So what you do with that least common denominator is you multiply your whole equation by that common denominator over 1. Since we're multiplying both sides of the equation by the same number, we're multiplying by 15 over 1, it's not going to change my equation. It's going to make it simpler. So when I'm multiplying by 15 over 1, I have to distribute this 15 over 1. So I'll do 15 over 1 times the a over 5. Now I'll do minus 15 over 1 times a plus 7 over 3 equals 15 over 1 times negative 1 over 1. So I just take this common denominator, put it over 1, and just multiply by each term in my fraction. Now this still looks pretty complicated, but you'll see how this will get simplified. Over here, remember what we said about multiplying fractions. We look if there's anything we could cancel out from the numerator and the denominator. And I picked the number that will make all those denominators disappear. Here, the 15 and the 5 can be both divided by 5. Over here, I'll get a 3. Over here, I'll get a 1. And now I'll just multiply the numerators together. 3 times a is 3a. And 1 times 1 is 1. Now remember, 1 in the denominator doesn't have to be written. 3a means the same thing as 3a over 1, so it's easier just to write it as 3a. And now go to my second. Here I have a 15 and here I have a 3. So I can cancel out the 3 into the 15 and get 5, and the 3 cancels out. And now I'm going to take that negative 5 over here and multiply it by the a plus 7 over here. Now I could have either do the multiplication right now, but right now I'm just writing. Again, the denominator is 1, so I didn't bother writing the 1 in the bottom. Over here, nothing cancels out, so I just have the 15 times negative 1, which is negative 15. And if you notice, from a equation that has a bunch of fractions, I now have an equation that has no fractions. It's a much simpler equation to solve. And when I solve this equation, it will be the answer for my original equation. So let's finish this equation. We'll get 3a. Now I'm going to multiply by negative 5. So negative 5a minus 35 equals negative 15. I'll combine the 3A and the negative 5A, which will give me negative 2A
Can I ask you a question?
minus 35 equals negative 15. Yeah, what's your question? Somebody have a question?
You got the 35 when you multiply the 5 with the 7, right?
Right.
Yeah.
I use the distributor. Remember, this negative 5 is times the whole A plus 7. That's why I had to put it. When you have something in a numerator, it's as if it's in a parentheses. The parentheses, I had to write the parentheses in because it wasn't just the negative 5 times the A, it's times the whole A plus 7. So I had to multiply the negative 5 by the A to get the negative 5A, and the negative 5 times the 7 to get the negative 35. Okay, now I'm going to add 35 to both sides, which will give me negative 2A. This is not gone. Now, negative 15 and 35 gives me positive 20. And then I'm going to divide by negative 2. And 20 divided by negative 2 is negative 10. And the answer to my equation comes out to be negative 10. Notice once I got past this initial stage, I didn't have to find I didn't have to add fractions, I didn't do anything like that. I did have to do multiplication, which is not so hard, but it ends up with being an equation that doesn't have any fractions. We're going to see, even when we get more complicated examples like this as we go along, this method of using the common denominator will help us to make it a simpler situation. I'm going to give you one to try on your own. And while you're trying that, I'm going to get your attendance. You're confused. I'm sorry. I'm going to read 3A. I combined this 3. I got the 3 over A over here. And over here, I had a negative 5 times A, which gave me a negative 5A. I combined the 3A and the negative 5A to get negative 2A. Is that clear? Adina, are you okay now? Okay, I see you answered me. Okay, I'm going to put another problem on the board, a somewhat similar, not exactly, but something that will give you a chance to try a similar type problem. It's y minus 3 over 2 minus y minus 1 over 7 equals 1 over 14. Okay, I'm going to give you time while I'm taking attendance. You try and do this problem, which again has fractions in it. And let's see if we can get that, because this is an important thing that we should be able to do.
I can't see what I can't see like the bottom row of the first equation that you like. I don't know what the equal sign says.
You don't see over here all the way at the bottom?
Yeah, like at the bottom. I don't know.
Final answer? Is this helping? You see it now?
Yeah, I can see it now. The camera is just a little bit blurry.
I don't know if I see. It's interesting. When I look at my screen, I try to see what you're seeing on the screen, and on my screen it seems to show, but depending on what device you're using. Okay, were you okay now?
Yeah, it's good now. Thank you.
Okay, I'll try not to write so low next time. Okay, so we're just listen for your name. Maury?
Here.
Good. Chelsea,
Here.
good. Ariana,
Here.
good. Adina, well, I know I just spoke to you, so I know you're here. Lachey, Lachey here?
I'm here.
Good.
Yeah.
Tamia Andrea Brown. Is Tamia here? Kava. Kava Collingwood. Terrence Cruz.
I'm here. I'm here.
Good. Karide,
Yes.
I hope I'm saying it right. I saw you.
You
on. I'm okay?
Yes.
Great, thanks. Kizia,
Kezia, I'm here.
good, thank you. Faith Diggs.
Here.
Oh, good. Is this your first time that you're here?
Yeah.
Okay. So I'm not wrong. Ethan,
Here.
good. Isabella,
Here.
good. Serenity,
Here.
good. Reggie, I know you're here because we were talking.
Here.
Zamia Grady,
I'm here.
good. Brandon,
Here.
good. Michaela,
I'm here.
good. Seraphine,
I'm here.
good afternoon, good. Marissa Paris. Renee,
Here.
hi. Sky,
Here.
hi. Good. Jaden Roberts. Kennedy, Felicia. Felicia,
Alicia, and I'm here.
oh, good. Natalia,
Here.
hi. Michael,
Here.
good afternoon. Cassidy Tucker,
Here.
is this your first time?
Yeah.
I didn't hear, I didn't get an answer.
Oh, yeah.
Okay, good. Anyway, welcome. Megan Vanzi. Kalia Watson. Lauren,
Here.
hi, how are you? And Kayla Zachary.
Here.
Okay, good. Okay. All right, let's see if we can work on this together now. Kennedy, okay, you're here. I'm glad you. Okay. I see some people have the answers, so let's see if we can use the method that I mentioned before to solve this. So we have fractions. Actually, each one of our terms is a fraction. There's nothing that has to be put over 1 because they're all fractions. And the largest denominator I see here is the 14. And if I notice, 2 divides into 14, and 7 also divides into 14. So actually, my LCD is 14. 14 is a number that every single term will divide into. So I take the 14 and put it over 1 and multiply my whole equation over 1. So it'll be, I always do the rewriting, even though it might take a little extra time. I'm distributing this 14 over 1, so that's in front of each one of these fractions. Okay, so I'm multiplying the 14 by this fraction, and by this fraction. I'm using the distributive property. So in this first group here, I have a 14 in the numerator, a 2 in the denominator. I can divide the 2 into both of them. 2 into 2 is 1, 2 into 14 is 7. So this just becomes the 7 times the y minus 3. Right? That takes that first fraction. Now on the second fraction, there's a 7 and a 14. I can divide the 7 by 7. That'll give me my 1. And the 14 divided by 7 is 2. So therefore, I'll have a negative 2 times y minus 1. Notice I don't have to put in any denominators because all my denominators are 1. In the last case, on the other side of the equation, I have a 14 on top and a 14 on bottom that I could divide out. So I just have 1 times 1, which is 1. This actually, though it looked maybe more complicated, turned out to be an easier problem because now I have just a regular equation without any fractions. I remove my parentheses, 7y minus 21, multiplying this by 7. Now I'm multiplying by negative 2, negative 2y plus 2, don't forget negative times negative is positive, equals 1. I combine my like terms, 7y and negative 2y is 5y. The negative 21 and the positive 2 is negative 19. That equals 1. Okay, I'm trying to keep this up higher. I have to add 19 to both sides. That'll give me, I'm going over here, 5y equaling 20. And then I can solve this by dividing by 5 so that my y equals 4. And I got an answer, y equals 4. Let me see, is that what my, on the chat, yes, I see those people, a couple of people did get that answer. Very good, excellent. Those of you who got that right. That was really good. So we now can solve equations with regular numbers, with decimals, and with fractions. So I'd like to now talk about something that is an application of equations. We're going to, applications are just real life situations where we could figure out the answer to it by using an equation. And they're going to be throughout the term different applications that we're going to try and learn. instead of trying to do all the applications at once, I'm gonna intersperse it in the course. Most people really don't like to do what we call word problems. But actually, if you can't do a word problem, if you can't take something that's a story that's described in English language, which is what we're using, and then interpret it mathematically as an equation to solve it, then you're really not getting much use out of your mathematics. The whole point of it is that we should be able to apply the things that we're learning to real life situations. So I'm going to erase this problem, and I'm going to talk about problems. As I said, we're only doing as one type at a time. Today, we're going to be talking about problems that have to do with finding the perimeter of a rectangle. Okay, so first of all, what a rectangle is, I'm sure everybody is familiar or would recognize a rectangle. It's a four-sided figure where all the angles that you have are what we call right angles. They got square corners, and the two opposite sides are equal. One pair of opposite sides are called the length, and the other pair of opposite sides are called the width. In other words, these two are the same. We usually call these, because they're the longer ones, the length. These two are equal, and they're called the width. If you look at around your room, you'll see so many places where you will see these rectangles. Actually, let's say the board that I'm writing on is a rectangle. The screen of my computer is a rectangle. We live in a world where the rectangle is a very, very important building block. Now, what if I wanted to put a frame around this board? I wanted to put tape all around, let's say I wanted to tape all the edges of this whole board. What I would be interested in finding out would be, how much is it all around? That is what we call the perimeter. The perimeter of any figure is the sum of all the sides of the perimeter. Where would you use a perimeter? As I said, let's say we wanted to do a frame on this board. Or let's say you had a garden in your backyard that is the shape of a rectangle, and you want to put a fence around that. What you're interested in is how much is it all around, and that's what we call the perimeter. Now, the easy way to find a perimeter of any figure is just to simply add up all the sides. For example, if I told you the length of this perimeter is 14, and the width of the perimeter is 8, and I asked you what is the perimeter of this, I know that this side would also be 14, and this side would also be 8. And all I have to do is 8 plus 14 plus 8 plus 14 to get my perimeter, which is called the perimeter P, which would be 16 and 28 is 44. My perimeter would be 44. Let's say it's feet. But I don't know what the measurement, what we're measuring. It could be feet, could be inches, could be meters, whatever. An alternate way of doing this is to use the formula that the perimeter is 2L plus 2W. In other words, I could multiply the length by 2, which would give me 28. And the width by 2 to give me 2 times 8, which is 16. And when I add the 28 plus the 16, it also gives me the 44. So either I could use this formula or I could just use the basic idea. When you're finding the perimeter of a rectangular shape, you're just adding up all 4 of its sides. Okay, that being said, let's see what kind of questions we could be asked that have to do with perimeters. I'm going to write a problem on the board. Here's what we're being told. The length of a rectangle is 2 more than the width. The perimeter is 80. What are the dimensions? Okay, so let's see if we can analyze this problem. Notice in this problem, I told you what the length and the width is, and we figured out the perimeter. Here we have the opposite situation. We know what the perimeter is. We know that all around, if I added all the 4 sides together, what I would get is 80. And I want to know how much are the dimensions. When we use the term dimensions, we want to know what is the length and what is the width. We want to know both of them. The dimensions is a generic term for both length and width. And we can solve this by setting up an equation. Now, here's what I'm going to draw a little picture of what's going on here. I'm told that the length is 2 more than the width. I'm being given a description of how long it is based on how wide it is. So let's call the width x. We don't know what its width is. We know, so we're going to call it x. And then we'll know that the length is 2 more. Now, 2 more, when the term more is used, it means you're adding 2. If it would have said 2 less, it would have meant that you're subtracting 2. And 2 more, even though the 2 is coming before the width, when we write it, we write x plus 2. To say something is 2 more means that we're adding 2 to the width. So we're getting x plus 2. Now I can just call this side is also going to be x because it's the width. And this is going to be x plus 2 because this is a length. 2 of them are lengths, 2 of them are widths. And now I can add them all up, x plus 2 plus x plus 2. That's all going to add up to whatever my perimeter is, which happens to be 80. And now it's just a simple equation to solve. Add up all the x's, so I get 4x. The 2 and the 2 gives me 4. Then I'll subtract 4 from both sides. Regular equation now. 4x equals 76. And when I divide by 4, the 76 divided by 4 gives me 19. that tells me that the width is 19. Now I asked for the dimensions, which means not just the width, you want the length as well. I know that the length is x plus 2, and the x is 19, so it's 19 plus 2, which is 21. So the length of this is 21. The width is 19. Sometimes when we write the dimensions, we write it 21 by 19. We use a little x to write. This is, but it would be equally equivalent to write the length is 19 and the width. The length is 21 and the width is 19. So that's how you would solve one of these questions that involves perimeter. I'm going to give you one to try on your own. Okay, suppose I told you that the width of a rectangle is 5 less than the length. And the perimeter is 70. And I want you to find the dimensions. Give you a few minutes to try that.
Miss, so like the whole what's it called? The whole perimeter is 80, right? That's the perimeter of the rectangle, right? The whole perimeter.
The perimeter is 70.
Oh, wait, in this question?
On this problem, I said the perimeter is 70. The one that
Oh,
I
it's
asked
never
you to,
gonna be it's not always gonna be the same.
no, because different rectangles have different perimeters.
Oh.
Sometimes it'll be 80, sometimes it'll be 20.
Oh, so it depends.
Think about it.
So it depends which one it is.
It depends, you know, like if you were talking about the perimeter of a swimming pool, it might be very big. Whereas if you're talking about the perimeter of a window, which could also be the shape of a rectangle, that'd be much smaller. So depending on what the object is, its perimeter is going to be different. Does that make sense to you, Reggie?
Yeah. Thank you.
Okay. That's why I'll always have to indicate to you what that perimeter is, because it could be different numbers in different occasions. Okay, that I see we're getting a bunch of answers. Don't forget, when you're asked about the dimensions, it's not enough just to give the width or the length. You have to give both of them. Okay, let's see if we can do this together now. Here's my picture. I always like to draw a picture when we're talking about rectangles. The width is 5 length less than the length. Okay, in this case, what they're giving me is the width in terms of the length. The length is the initial thing, so let's call our length x. And that'll mean our width is 5 less, which means I have to subtract 5 from it. That means I have to do x minus 5. Now, when you're using plus, it doesn't matter if you write x plus 2, but if you wrote 2 plus x, that would be perfectly correct as well. And you would get that problem completely right. With more, when you have a plus, the order in which you write it doesn't really make a difference. But when we have less, we have to be very careful. 5 less means we're taking our x and subtracting 5 from it. It's not 5 minus x, it has to be x minus 5. Now, if this one is x minus 5, this one will also be x minus 5. And if this is x, this will also be x. And remember, we said the perimeter is 70, which means I'm going to have to do the x minus 5 plus the x minus 5 plus the x to add up to the 70. I add all 4 sides up. Notice that gives me 4x minus 10. Because the negative 5 and negative 5 is 10. That equals 70. And I solve this equation by adding x to both sides, 10 to both sides. That gives me 4x equals 80. And that means that my x is equal to, when I divide by 4, 20. That means the x is 20, which means the length is 20, because that's what I used x for. And the width is x minus 5, so that's 20 minus 5, which is 15. So I could say it separately. The length is set at 20 and the width is 15, or I could write it as 20 by 15 as the dimensions. I could write it that way as well. So that's how you would solve. I see a bunch of people did get that correct, and that's very good. Okay, so we basically have covered the work that we need for chapter 1. We don't forget to be looking for more homework on Delta Math on chapter 1. You thought 2 negatives was a positive. Where are there 2? Not when you're adding. When you're multiplying, you multiply a negative times a negative, it's a positive. But when you add a negative 5 plus a negative 5, you get a negative 10. If you're not sure, I'll test it on your calculator and you'll see. If you put in negative 5 minus 5, it will give you a negative 10. Be careful as to what operation you're doing. If anybody came on and was signed on after I took attendance, please make sure to send me a note on the chat that you came on. Okay. So I want to now start on chapter 2. Chapter 2 is a chapter on graphing of points and lines, what we call linear equations. And what I'd like to do today is just review with you, because I know you've done some graphing, just to review today of how to graph points on a graph and also how to graph the equation of a line. So, okay. So, first of all, if you notice my beautiful graph paper, I don't have graph paper. I have a regular board. Can I do graphing on a regular board? I certainly can, but it's not very exact. I suggest that if you want to do some graphing and you want to really get a feeling for the graph, get yourself some graph paper. Don't do it just in your regular notebook, but do it on either on a graphing notebook or on graphing paper, so that you can get an idea of what it really, you get a much better sense of what's happening, and your graphs will be much more accurate if you do that. Okay, when we graph, the type of graphing that we do, we're not just graphing on a number line, but we're graphing on what we call the whole plane, the whole flat surface. And we have two lines that we start off with. One is a horizontal line, which is called the x-axis. It is simply a number line. Say this is the 0, the right is the positive numbers, the left is the negative numbers. Through that 0, we put a line that goes straight up and down, a vertical line. And we call that the y-axis. And the point where they meet is what we call the origin. And what we do is, to graph something, a point has to have two numbers, something called two coordinates. Something like this. Let's say I have -2, +3. This is what's called an ordered pair of numbers. Ordered because it's very important which number comes first and which number comes second. We enclose it in parentheses so that sometimes if you just gave a list of numbers, you wouldn't know that you're talking about points. When we use this parentheses, it indicates that what we're talking about is a point. And for one point, we need two numbers. We need an x coordinate and a y coordinate. And the way we get to that point is we take the first number, which is the x coordinate. We start at the 0 or the origin. And -2, we go, the first number always indicates left or right. -2 means go 2 to the left. And then you use your second number for going up or down. The next number I have is 3. So from this point, I go up 3. And that point that I got by going 2 to the left and 3 up is the point that I'm talking about. And I very often say, oh, I'm talking about the point -2, 3. Now, that's really not good language, because if I tell you if I'm talking about a point, -2, 3 is not a point, it's numbers. But when I say I'm talking about the point -2, 3, what it means is I'm talking about the point on the plane that I get to by going 2 to the left and 3 up. I could have a number like a point like this.
Excuse me.
Yes,
I'm sorry. I just can't see what the points is on the right hand side. No, my right.
there is no point.
No, but yeah, what you have in parentheses on this side, not the -2 and 3. I can't see what that's.
There's nothing there. It's just, I'm trying to, I don't understand what you mean. There's
Okay,
one-
so right in your point in the middle, there's like something right there, but I can't see because of like it's like a little blurry.
Oh, it says origin.
Okay, I'm sorry.
And you know what? I'll even erase it because it's not, it's just the name of that point.
No, it's not you. It's just a little blurry, maybe because of my connection.
Okay. It's not so important. This is, that point right here is what we call the origin. I think you probably know that, right?
Yeah, I did know that. I just wasn't sure if you had numbers there.
Okay. I'm sorry. I hope it's not my computer that's not clear.
No, it's probably mine. It's okay. I'm sorry.
Okay. What if I gave you the point, -1, -5? Where would that point go? Does anybody have any idea? How would I get to the point -1, -5?
Can I
To the
go?
left down.
Oh, sorry.
1 to the left down. Sorry.
Right, I'd first go 1 to the left, because that's a -1. Remember, the first point always tells me left or right. And then I'd go from there 5 down. And that would get me to this point. What if I gave you this point over here? What if I put a point there? Could you tell me what the coordinates of that point are?
Can I say it?
You have to talk louder.
Oh, can I go?
Yeah,
Oh, sorry. So you said, so that should be like around 2. No, I mean -2 and 4 and +4. Like where the coordinates.
okay.
Next
And
we
the
have
4 is the number that has to go first because the 4, remember, we always.
Oh,
go
because it
left
is
and
on
right
the positive side. It's on the positive side. That's
Right, it's on the positive side and it's to the right, so we put the 4 first, then we're going down 2, so that's -2, which is what you said. But be careful not to write it -2, 4. This is what's called an ordered pair because the order in which you give the numbers is very important. The first number always gives you the left to right number. The second number always gives you the up and down. So we see, and what about the origin? Anybody want to tell me what the coordinates of the origin are?
0, 0.
0, 0. Good. Okay, so I think everybody knows how to plot points, and if you have a point, you can give me what the name of the point is. We're now going to talk about lines. Every single line that we're going to draw on this graph will have an equation that's called a linear equation. The word linear from the word line. Later on in the term, we're going to do some equations that are not linear, something like quadratic equations. We're going to see when we graph those sort of things, we're going to get other shapes. In order to get a line, we have to have a linear equation. And I can recognize whether an equation that I give you, remember there's going to be an x in the equation and a y in the equation. In most equations of lines, you're going to have 2 variables, an x and a y. But you're not going to have any exponents. You're not going to have an x squared. You're not going to have a y to the 3rd. You're not going to have the square root of x or anything like that. The x is going to have a exponent of 1, which means it really doesn't have an exponent. It's understood to be 1. And the y is going to have an exponent of 1. The most you're going to have is a plain x and a plain y. So sometimes these linear equations are also called first degree equations. We talk about the degree of an equation being the highest exponent. So if we have an exponent of 3 in my equation, if I have something like an x to the third, that would be called a third degree equation. But for lines, we can only have first degree equation. We can't have an exponent higher than 1. Okay. Now the question is, what if I give you a linear equation or a first degree equation? How can you go from the equation to drawing the line? That's what we're going to do now. Next, after that, next week, we're going to talk about the opposite. What if I give you a description of the line? How are you going to get to its equation? But today I'm going to give you an equation, and we're going to talk about how we can possibly graph that equation. And again, most of this is work that you have seen before. So I'm going to just take any old equation. I'm going to write on the board. Let's say I have this equation. 2x plus y equals 3. It's definitely a linear equation because I don't have any x squareds. I don't have any y squareds. It has an x and a y. This equation happens to be in what we call the standard format. The standard format of a linear equation has the x's and y's on one side and a number on the other side. We want to go from the equation to the graph of the equation. We want to be able to draw the line. And I'm going to show you today 2 ways in which it could be done. And I'm going to tell you which way I prefer. And then maybe next week I'll show you even a 3rd way of doing that. But today we're going to do 2 different ways of it's called graphing the equation. One method is called plotting points. Or just making a chart of values, where you'll pick one number to be the x, and you'll use your equation to figure out the y. For example, you're going to pick, you can pick any number you want to be for x. Let's say I pick x to be 0. I always like to pick 0 for x because it's an easy number to work with. If I do that, I'll get 2 times 0 plus y equals 3. And 2 times 0 is just 0, and 0 plus y is just y, so that my y turns out to be 3. In other words, one of the points on this line is the point 0, 3. That is, actually, that's the connection between the points on the line and the equation. If a point works out to fit the equation, then it's on the line. If a point doesn't work out in the equation, it's not on the line. So one of the points on my line is a point 0, 3. Let's put it, here's my equation. Here's my line, here's my graph. Where is a point 0, 3? Where should I go to get to point 0, 3?
We would stay on the origin in the middle and go up 3.
Right. I always start at the origin. The first number is 0, so that means don't go left or right, but the 3 is the second number, the y coordinate. That means go up 3. In other words, here's my point 0, 3. This line that I have that I want to draw is going to have to cross through the y-axis at 0, 3. We sometimes use the term the y-intercept. Y-intercept means where it's crossing the y-axis. The y-intercept is 3. Okay. But that's only one point on the line. The line could go any which way. I need at least one other point on the line. So in order to get another point on the line, let's take another value for x. Shall I take 2? This is totally arbitrary. I could have taken 2. I could have taken 100, but I don't think I want to try and count to 100. I don't mind counting to 2 on my graph. It could have been -2 if I wanted to. Well, if I pick 2 to be the x, then my equation then becomes 2 times 2 plus y equals 3, because I replaced the x now with 2. So I have 4 plus y equals 3. And I'll bring the 4 to the other side. And it gives me y equals -1. So another point on this line is a point 2, -1. That means I could have, another point would be if I went 2 to the right and 1 down. Notice I now can draw the line, because if as long as I have 2 points, I can connect the 2 points. I go further up and down, but I get a line that looks like this. This is my, how I got the line by plotting points. It always works. The only problem with plotting points is that you'll have to constantly be solving at least 2, and if you want to be more accurate, you want to make sure you did it right, then you have to do 3. This is one method of graphing a line. There is another method. And I'd like to show you that other method, and then that's where we will continue from next week. So here's the same question, alternate method. It's called using what we call the slope intercept method. What we do is we start with our equation, starting with the exact equation that we had before. And I solve for y. I get the y by itself. Well, in order to solve for y, I've got to bring this 2x to the other side to get the y alone. So this is going to give me y equals, now I have 2 numbers here. I have a 3 and a -2x. Those are not like terms, so I have to leave them separate. The only thing is that to put it in what we call the slope-intercept form of the equation, we always want to have the x term first and the number separate. This is sometimes called the y equals mx plus b form of the equation. So we make the y by itself. We have the x term next and the number without any x term second. The number in front of the x, the coefficient of the x, which in this case is -2, is what we call the slope of the line. And the number that stands alone, which is the 3, that's what we call the b, is the y-intercept. Now, let me show you, I want to leave this on the board to show you that really we're getting the same line. So I'm going to do it over here. How do we use the slope and the y-intercept to graph the line? Well, the y-intercept we know is the point on the y-axis where the line is going to cross. To say that the y-intercept is 3 means I have to go up 3 on the y-axis, which is exactly what we gotten before. But the y-intercept only gives me 1 point, and I need 2 points at least. I need another point. And that's where the slope comes in. The slope, another way of saying the slope is, slope means how it's slanted. It's what we call rise over run. Actually, I always want to write the slope as a fraction. Now, I got the slope to be -2. That wasn't a fraction, but that can be written as -2 over 1. Anytime I have a whole number, I can put it over 1 and it turns into a fraction. I'm telling you that the rise is -2 and the run is 1. That means from this point over here, because I have to start from a point that I know, and that's always, I always start at the y-intercept. I'm not starting at the origin, I'm starting at the y-intercept. And from there, I'm going to go down to, because rise -2 means go down to, run 1, go 1 to the right. That'll give me a second point. I could do that again. I could keep doing this. I could rise -2, in other words, go again down to, from this new point, 1, 2, and 1 over. Do you see how I get a bunch of points that line up? Actually, instead of writing this as -2 over 1, I could have written it as 2 over -1. When you have a negative in a fraction, it could be either on the top or the bottom, which means that I could have also risen to, that means go up to, and run -1, which means go 1 to the left. And if you notice, these all line up and gives me the exact same line I had before. This is actually the method that I prefer. Once you've solved your equation for what, just solve your equation for y, then you can right away go to your graph and graph the line. Okay, so we're going to be starting next time on graphing. We're going to do some more graphing, and then we're going to talk about what if I give you a picture? What if I gave you this picture and I didn't give you the equation? How are we going to get that equation? So that's the next thing we're going to be working on. Okay, have a nice week. Remember, we're not meeting on
I have a
Tuesday.
question.
School is closed. Sure.
So
Go
is
ahead.
the run always gonna be -1 or 1 for any equation?
Are we going to, I'm sorry, I'm not following the question.
I said if the run, like the rise over run, the run is always gonna be 1 or -1.
No, it's sometimes you might have a slope. Let's say it turned out that your slope was 2 over 3. You could have a fraction as a slope. Then that would mean that your rise is 2 and your run is 3.
Oh, okay.
Whenever your slope is a whole number, then it's going to be over 1. But if it's a fraction, then it right away is in the rise over run form. Did that answer your question?
Yes.
Okay.
Thank you.
Okay, so as I said, we're not meeting on Tuesday. School is closed, I think, on Monday, and Tuesday, I don't know, Tuesday and Wednesday, there's no school. So our next class is going to be next Thursday, and we will be talking about further examples. And maybe we'll even talk about having a quiz, but then I won't give you a test or quiz without giving you proper notification, at least a week's notice. So we'll talk about it next time if we want to have a quiz. All right. I hope you have a good day. Stay healthy and stay safe. I hope nobody, I'm glad as many people were able to get on as we had in class, because I was sure that people